Yeah. Oh, there we go.
Just bear with us a second.
There we go.
Okay. Let's talk about some implementation lessons from our work. A little bit now about physical layer. I think that this is where a lot of folks get tripped up in their deployments. We talked about what's the goal for each camera, but we need to talk about when and where you're interested in the views. For each camera, you should be taking a schematic drawing of the area and starting to draw the view that you'll get for that, and then trying to determine if there's anything that's going to block that view. Vehicles, sunlight, trees, those sorts of things. So getting the view component right first is really the driver. So you understand what you're looking at and how you're going to get to that view. As you do that, I'll make mention that a lot of the driver of the install, at least on the wired camera side, is determining what the best access is for the physical plant, for the wiring. So the high-resolution cameras that are available today, you may have different options for mounting that give you the same view. So if you come from both a north position on a building at 300 feet and a south position at 100 feet, and still get the same resolution. So you want to be looking at what those capabilities are for the physical plant and what the easy mounting pieces are. That's usually driven either by IT, but often by facilities, because you're talking about interoperation with other building mechanicals to try to get to certain places. So we're talking about what's the most economical mounting for that, and then also what's most tamper-resistant, right? So whether or not you buy the tamper-resistant installation kits for the cameras, make sure that you use mounting hardware that is tamper-resistant. Make sure you use Allen head screws. It's a little harder than people just carrying a screwdriver. Make sure you make some of the hardware decisions that you can that help make your cameras both physically difficult to get to and physically difficult to dismount or change mounting. Then the next piece is power. Most of the cameras, for cost reasons, that you'll be looking at are Power over Ethernet. Power over Ethernet comes in a couple of different variations. The original standard called AF is basically a lower power piece, 4 or 7 watt power. And as you move to the higher layer, higher power for your pan tilt zoom cameras, your PTZ cameras, you want to consider being able to support Power over Ethernet at 29 watts. So that's the maximum allowed on the Power over Ethernet Plus component. I'll make mention that I've written a little white paper on this, but creating a power budget for your cameras is critical. So that's what you're doing around that is you're basically determining how much power your Ethernet switch is going to allow, and then making sure that your switch supports that amount of power for your cameras. So power for cameras, power for PTZ cameras, plus illuminators will give your total draw, and you just need to make sure that your switches support that. Most Power over Ethernet switches will not support full rate power distribution across all ports. 48 port switch will not support 48 ports of PoE+.